that last little piece. Both operons have regulatory genes that begin early on in the whole piece of DNA. So your regulatory gene is near the beginning, and they both make repressors. Okay, they both make proteins that can fit in and repress. The lac operon, her repressor is always shaped correctly because she is typically off, right? The trip repressor is shaped funny and doesn't fit because he's typically always on. All right, so the main thing here is that we remember that our two operons, trip and lac, are just two very specific examples of operons. There's lots more, but trip represents an operon and lac represents an operon off. Okay? So to turn our lac operon on, we have to have the presence of lactose or some form of lactose. Therefore, this operon is considered inducible. Okay, and that means we can make it turn on. Trip operon, always on, because it needs to make tryptophan. But when the tryptophan levels get too high, excess tryptophan can be a co-repressor and turn the operon off until the tryptophan levels go down. Okay, so it's like a negative feedback. It can come back up here and turn itself off and slow down the process. The lac operon is only going to turn on when lactose is present because there's no need to waste time and energy. All right, so tomorrow we're going to talk about how eukaryotic cells turn genes on and off. And so on your assignment, I asked you to draw a couple of things. The first thing I wanted you to draw was the process here that's in the book. And this we've talked about. This is a signal, goes to the chromatin, DNA gets transcribed, and then it makes a piece of RNA, and then we process it and remove pieces, and then we add a cap and a tail, and then it leaves the nucleus. This purple bubble's our nucleus, and it goes to the ribosomes and gets translated. It makes a protein, and then the protein does all its folding, and then it's either used, shipped out, or degraded. But the process of turning all of this stuff on is going to be on page 311. So tomorrow that's what we're going to talk about, and we're going to talk about how this strand of DNA wants to take this gene and make something from it. But it's going to fold over on top of itself, and actually the touching and the folding over of this piece of DNA, and this is your little switch, gets everything started. So if you'll make sure you draw this picture tomorrow so that I can label it for you and we can go over, and then we'll talk a little bit about this picture on page 312 as well. And then we'll have some questions, okay? So I will schedule a Zoom meeting for Friday, and after that, you have a quiz on College Board, and then you'll have an online multiple choice test for me, okay? All right, see you later. Bye.